Hello Precalculus student, this video is for chapter 4.5, Properties of Log Function. We are going to look into some special features of log function that can allow us to simplify log function values better. In terms of function values, in general, we know that if I have function f of 1 plus f of 2, it is not equal to f of 3, right? We know that. So that's something that we don't know. So one special example would be if f of x is equal to x squared, you can tell that if you plug in 1, it is 1. Plug in 2 is 4. If you add them, it's not equal to plug in 9, right? So that's one thing. And also, if I have f of 1 times 3, it is not equal to, you cannot move the 3 inside. It's not equal to f of 3, right? The same, you can use this same answer, same function. So if you have f of 1 is 1 times 3 is just 3, but f of 3 is 9, right? So in general, you can move a scalar or a multiply inside the function. You can combine function by adding them together. So that's in general true. And also, if I have f of 1, f of 4 times 3 in a function, you can split it up as f of 4 times f of 3, right? So in general, they are not okay. For example, your f of x is equal to x plus 1, right? If it is x plus 1, this will be 12 plus 1 is 13, but if you do f of 4 times f of 3, it's not 13. So they are okay in some times, but most of the time they're not. But there are some properties in log that makes some of this possible. So we know log base 10, 10 is 1, log base 10, 100 is 2, log base 10, 1000 is 3, right? If I add log 10 and log 10, everybody knows is equal to 2, right? But what about 10 plus 10? It will be log 20. It's certainly not equal to 2. So this is just valid for any function. If you add two of these together, you cannot just move them together and add them. So they are not equal. And also if you have log 10 times log 10, that would be 1 times 1. But log 10 times log 10 times 10 would be 100. So this is also not equal. So these are generally not possible, like what we have talked about before. But there is one special one that is really strange is if you do log 10 times 10 is 100, that's equal to 2. But if you do log 10 plus log 10, this is 1 and this is 1, that is also equal to 2. So this is equal. Now you may say, Ms. Chen, maybe it is because this is log base 10 and you're doing 10. And in fact, it is not. You can have any base. If you multiply two things inside a log, you can split them up into 2 as add. So this is just one special case, that's right. But if you replace it by 3 and 4 or another base, they still work. Okay, so try another one. If I do 100 times 10, that would be 1000, right? It will be log 1000. That's equal to 3, right? So that would equal to log 100 plus, because I can split it as add plus log 10. So multiply, split it as adding two different log. And another one we can see is log 1000 can also be 3 times log 10. So it seems like this exponent can move to the front, outside of the log. So this is also equal. Okay, so let's summarize the property that we have gone over so far. If you have log base b, but this base can be anything greater than 1 or greater than 0, then log base m times n, so it has to be multiplied. You can split it as log base b, the same base, m plus log base b n. Multiply, split into two individual add. Or you can say when you add two different logs, you can simplify them by combining them, condense them into one log. Quotient rule is when you have the same log base b, m divided by n can be split into log base b m minus log base b n. This is a direct result of the product rule. Power rule is log base b m to the power n. Now m to the power n is inside the log. You can pretty much move this n outside as a coefficient times log base b n. So this is called the power rule. All of them are very useful in calculus. Not to do calculus, but when you write the answer. So when you write answer, sometimes you have multiple log function or you have one log function. You can split them or you can combine them to make your life easier in calculus. So you need to know them. And this particular features only work for logs. So it doesn't work for other general function like x squared. It doesn't work. Okay. So remember also if you have inside the log adding, you cannot split them. You cannot split them as add because adding can be combined into multiplying. Okay, it would only this only equal to log base b m times n. Okay, you can combine to add into a multiply, but if you have a add inside a log, that is the simplest. Cannot split. Okay, cannot split. Cannot expand them into individual logs. So let's do some examples. Use the log property to evaluate log without calculator. So one of the most important use of the log properties is you can use this to evaluate log. So let's say we have a log base 2 and then has a fourth root of 8. So let's write 8 as a power of 2 is 2 to the third, right? So this would be log base 2 right as a power. So 8 to the 1/4. But 8 is actually, so, and then we can say move it outside because I don't know how to do 8 to the power 1/4. So because it's an exponent inside a log, I can do 1/4. And then log base 2, 8. Log base 2, 8 is 3 because we know 2 to the 3 is 8. So this set is 3. So that's 3 over 8, 3 over 4. So this is equal to 3. And then ln cube root of e squared. So we're rewriting cube root as an exponent, right? E squared, and then 1/3. So we can simplify the exponent by multiplying them. It will be 2 over 3, e to the 2 over 3. And then move the 2 over 3 outside, so it will be ln e. ln e is 1, right? So this is 1. So that's equal to 2/3. We can also simplify log expression like this. Log base 575 log minus log base 53. So in a nutshell, you can simplify this because you can write 75 as a power of 5. You can write 3 as a power of 5 also. But because it's a subtraction, you can combine them into what? Divide, right? 75 over 3. 75 over 3 is 25. After you divide them, it's 25, but log 5, 25 is equal to 2, right? Because 5 squared is 25. And we can also simplify this by moving by combining them again. Okay, so it would be 3. We can combine them when we have an exponent. So we move it inside first. So it'll be ln e to the e squared and then the cube. Move everything inside because we want to combine them. ln e to the 5. So this would be ln e to the 6 plus ln e to the 5. You can combine them or do them individually. So this would be actually ln and e cancel equal to 6. ln and e cancel equal to 5. That's 11. Or you can combine them and then just add the log, add the exponent. Either way is fine. Okay, so some of the standard question in log properties would be to condense a whole bunch of stuff into one single log, which is very useful in calculus. So after you do a whole bunch of calculus calculation, sometimes the answer key would not show this. They will want you to combine to one log. So these are all log 6. I think there's a typo here. So I can combine them because these are all adds, so they would become multiply when you combine them. So I would just say 3 times 4k times, what is it? Forgot. Is it m? So that would just be log base 6, 12 km. And that's it. So you have one log. So in calculus, they prefer an answer using one log. So if you finish your calculus calculation and it become like this, they don't like this answer. You have to use the log probably to combine them most of the time. Log base 5 minus log base 5b plus log base 5c minus 1. So I can combine them. If I see a negative, that means divide. If I see a positive, that means multiply, right? Combine as multiply. So I base log base 5 whole thing. A minus b means A divided by b, but I have to multiply, so this would be in the top. C minus 1. Remember, if you multiply, you add is multiply, you don't multiply at the bottom, you multiply in the top. So it'll be A open parenthesis C minus 1 over b. One log. The next one, you have two subtraction, right? So what do? Well, actually, before you combine, you have to get rid of this exponent first. So use log probably to move them in. B squared minus log base 7 a over 3. We don't want to split them. We just want to combine them. This over 3 means 1/3. So you can move it in. A to the 1/3 is cube root, right? A 1/3. This means 1/3 is equal to cube root of A. Right now we move everything so it's log, log, log. Now we can combine them. Both are subtraction. That means you have log base 7. You have to do divide. So the top would be b, right? Oh, b squared. They are both subtraction. That means they're all in the denominator. A over 3 times. Why do I do times? I am doing a division actually because it's division, so they are in the denominator, cube root of A. Now, we don't like this 3 hanging here, so this would be divided by 3 in the denominator. That means multiply by 3 in the top. So move it up. It would be 3b squared over A and A cube, all inside in one shot, like that. Last one, so we have to combine it again. So I have a subtract, which is divide. I have a multiply, which is in the numerator. But I need to get rid of these coefficients first. Okay, you cannot move them, combine them, or divide them if you have these outside. So move it as an exponent. So log base 2, what is m 1/3 means? Cube root of m. Minus, so log base 2, so do one step. M plus 1, I can't change anything of m plus 1. 2 means square, right? Plus log base 2, m squared minus 1, but 1/2, that means square root of m squared minus 1. So now you have moved all the coefficient inside, you're ready to combine. So log base 2, so which term is in the denominator is this one, right? Add is in the top. So cube root of m, and then the minus this, so means m plus 1 square. And then add this, that means I multiply in the top, m squared minus 1, and that's it. I can't simplify anything. Don't cancel things like this because they are not factor. Okay. So the next things is about expanding. So instead of combining, you're expanding. So it is useful in certain calculation of calculus. Sometimes you have a log of something and you want to expand them so they are very simple. In the calculus derivative, you often use these properties. And I'm going to talk about this in the next video.